Yes, you are most welcome to this lesson. In this lesson, we want to look at the reactivity series. Now, the reactivity series, we can compare it to real life situation. In real life, you realize that there are some people who are more powerful than others. By powerful, they can be powerful in terms of having a lot of money, maybe being in positions of authority, so they are above others in life. And those people who are above others in life are presumably more happy than those who are below them. That's what you can see here. You realize that this shows something that is someone who is very happy. And now the one who follows, or those who follow those other ones, are actually less happy. And as you go down that hierarchy of power, you realize that the one who is below, or the one who is lowest in that hierarchy, is less happy or less powerful. So the most powerful is on top, and the least powerful is at the bottom. That also applies to most elements. You realize that depending on how the elements react with other substances, we can arrange elements in a certain order, from the most reactive, from the most powerful to the least powerful. So that arrangement of elements in their order of reactivity is what we call the reactivity series. Okay? So the reactivity series is the arrangement of elements in their order of reactivity. The most powerful element always appears at the top of the series, and the least powerful element appears at the bottom. Okay, so it's something like this. The one who is most powerful sits at the upper stair, sits on top. Then down the stairs, the powerfulness or the power possessed decreases, meaning the reactivity decreases as you move down the stairs. Okay? And the least reactive, the one which reacts least, is the one which is now at the bottom. So you can see that these elements are arranged from the most reactive element, which in this case is potassium, to the least reactive, which is gold. So as you move down that series, the reactivity decreases. Okay, great. So we have here a summary of the reactivity series, with potassium being on the top, meaning that it is the most reactive metal in this case, and followed by sodium, which follows it in terms of reactivity, and then calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, and platinum. Now, hydrogen and carbon are actually not metals. They are just put there for comparison. Okay? So the major metals are those other elements apart from hydrogen and carbon. So the most reactive of all these metals is potassium, and the least reactive is platinum. Okay, so there is a simple way of remembering this reactivity series here, which you can choose to use, or you can create your own way of remembering. Here we have the first letters in the names of the elements of the metals being used to create words that you can easily remember. So it goes like, please stop calling me a careless zebra. Instead, try learning how copper saves gold. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So you can just remember this statement and try to compare. Please, the P there stands for potassium. And it doesn't mean that the symbol of potassium is P. The symbol of potassium is not P, it is K. Okay? So, and then the stop, the S there beginning in stop stands for sodium. And the symbol of sodium is capital N, lowercase a. And so on and so on. Okay, so there still we have the symbols of the elements. We have potassium, of course, which is capital K, then sodium, capital Na, and the rest. So here we are showing that the most reactive of all these metals in the reactivity series are sodium, potassium, or rather, the first one is potassium, and followed by sodium, calcium, magnesium, and aluminium. Those are the most reactive compared to carbon. Then the ones that are least reactive than carbon are zinc, iron, and lead. Those ones are moderately reactive. Then there are those that are actually less reactive than even hydrogen, and those are copper, silver, gold, and platinum. Those are the least reactive. But still within those groupings, there are those that are more reactive than others. For example, in the group of most reactive, potassium is more reactive than the rest. Okay? Good. Then, this reactivity series can really be applied in chemistry. One, to predict chemical reactivity of metals with oxygen, with water, with acids, and etc. Meaning that if you want to determine at what rate a substance or a metal will react with oxygen, you can look at its position in the reactivity series. Although some of the elements, some of the metals actually will not react with oxygen, most especially the ones that are very, very low in the reactivity series. Now, some of them can be forced to react with oxygen when they are heated. Okay? Great. So, there is a summary here of the comparison of how these metals react with oxygen, water, and acids. So over here, you have on the top potassium, and its symbol is there, capital K. And potassium is the most reactive with oxygen. So it reacts very vigorously with oxygen. As well, sodium is also very reactive with oxygen. So it also burns vigorously with oxygen to form a metal oxide. So which oxide will potassium form? It forms potassium oxide. Then sodium forms the sodium oxide. Okay? So these two are very reactive with oxygen. So they react vigorously. So vigorously is intense reaction. Okay? Now, the other grouping, we have calcium, which is capital C, lowercase a, magnesium, aluminium, zinc, and iron. These ones burn less vigorously compared to potassium and sodium. Why? Because they are lower, they are less. The calcium magnesium, aluminium, and zinc and iron are less reactive than the sodium and potassium. So they will burn less vigorously to form metal oxides, respective. So for example, if zinc burns in air, it will form zinc oxide. Iron burns in air, it will form iron oxide. Iron 3 oxide, or iron 2 oxide, or tri-iron tetraoxide. So that means that if you have to describe the reaction of any of these elements with oxygen, you can just look at its position in the reactivity series. Okay, then the next we have lead, copper, and mercury, which react very slowly with oxygen. So these ones will only react with oxygen if they are heated. So once you go to the extent of heating, it means you are trying to force that element to react with oxygen. Good. Then lastly, we have silver and gold. These ones do not react with oxygen. So there is no reaction with oxygen in that case. Then reaction with water, there are some that will react with cold water, meaning that they just react at room temperature. You don't have to force them to react. Then there are those that will react with heated water, steam. Okay, those ones we are trying to force them to react with water. Then there are those that will not react. So those that will react with cold water, we have potassium, sodium, and calcium. Why? Because they are very reactive. Then there are those that will not react with cold water, they will react with steam. Which ones are they? We have magnesium, aluminium, zinc, and lead, and iron. Okay? So those ones will react with steam, meaning that you are trying to force them to react. However, still within the groups there, you realize that calcium will be more reactive, rather magnesium will be more reactive than the rest. So magnesium will actually try to react even with cold water. Okay. Then we have those that do not react with water even when they are heated. We have lead, copper, mercury, silver, and gold. Okay. Then we go to reaction with acids. We have one, those that will react with strong acids. Okay? Those that will react with actually dilute acids, not strong acids. Then those that will react with concentrated acids. And lastly, those that will not react with any acid. Okay? So those that will react with dilute acids, meaning that they easily react, they are very reactive. Those ones are potassium, sodium, calcium, magnesium, aluminium, zinc, and iron. Then there are those that will not react with dilute acids, but with concentrated acids. We have lead, copper, mercury, silver, and gold. Those ones will react with concentrated acids. Okay, then we have another application of the reactivity series in predicting the products of competition for oxygen by metals. Now, in most cases, when you heat metal oxides with metals, for example, if you heated copper 2 oxide with magnesium, okay, you mixed them and heated them together, there is going to be a product which will be formed. Now, to predict which product will be formed, we shall look at which of those metals is higher than the other in the reactivity series. The one that is higher in the reactivity series will always remove oxygen from the one that is lower in the reactivity series. So, for example, magnesium, when it is heated with copper 2 oxide, magnesium heated with copper 2 oxide, or a mixture of magnesium and copper 2 oxide being heated, what we shall see is the magnesium being more reactive will remove the oxygen from the copper 2 oxide, because the copper in copper 2 oxide is less reactive. Okay, so you have a question like magnesium was heated strongly with copper 2 oxide. State what was observed and write the equation for the reaction that took place. Then give a reason for your observation above. So the answer is simple. State what was observed, meaning that what will be seen. Okay, so what shall we observe? The black solid, which is actually copper 2 oxide, turns to a white solid and a brown residue. So we have two colors being formed in the product side: brown solid and white solid. Okay, and the initial color of copper 2 oxide is black. So the explanation will be simple, that the magnesium being more reactive than copper will remove oxygen from copper 2 oxide, which is the black solid, to form a white solid of magnesium oxide and a brown solid of copper. Okay, so another question can ask you, name one, the white solid form, that is magnesium oxide. Then two, the brown solid formed, that is copper metal. Great. So more examples here. Explain the following observations and write equations in each case. When a mixture of carbon and copper 2 oxide were heated in a test tube, a brown solid was formed and a colorless gas, which turns lime water milky, was liberated. So still you have to look at the two elements, the carbon and the copper. Which one is more reactive? Carbon is more reactive than copper. So the carbon will actually remove the oxygen from the copper. So how will you write the answer? Carbon, being more reactive than the copper, will remove oxygen from copper 2 oxide to form the brown copper metal and the colorless carbon dioxide gas, which turns lime water milky. And the equation is there written. Okay, so this last example you are going to try on your own. Magnesium burns in presence of carbon dioxide, and a white hash of magnesium oxide and a black solid of carbon are formed. You are supposed to explain that observation. And that has been our lesson. Hoping that it was helpful. Have a blessed day.